We are minimizing, okay, we are technically approaching our target. What we do? We are technically approaching our target. This is the concept of the derivative which we are using our gradient descent approach of the AI concept.
Yes, sir.
Is it clear, please?
Yes, sir.
Yeah, good. I really apologize. Some of you people are already familiar with this concept. I repeated it, but okay, for sake of understanding, I hope you will never forget it again.
No, sir.
The concept is very much important. Study, you already, okay, will genius. I don't need to teach you anything. But how you will apply these things in AI, this is very important.
Yes, sir.
I also taught you people about the concept of a line. And from this concept of a line, I also taught you people about the hyperbola. This is the equation of line y equal mx plus c.
Yes.
फार्मूला खोला तो ये
You people familiar what's the intercept value?
Yes.
Okay. And what's the slope changing value? Similarly, this is the benchmark. Why the benchmark data? And our predicted, this one is the prediction data. It can be represent some, okay, like this hypothesis. If I am representing this hypothesis or with somehow like this one, and I also told you that this x sub naught, this one, always representing with 1. So your hypothesis equation will become like this one. So this is exactly like the equation of line, where theta naught, this one, representing the intercept value. Or you can say starting value. My children, this is the weight factor. It is very much important. If in case, simple case, for example, in the farmer case, I told you that the benchmark value of some 1 kilogram apple, this is a 10, but sometimes you don't know it. Especially in the AI case, robot, sometimes you should start it from the scratch. And once you start it from the scratch, then of course your theta somehow look like 0. You need to update the system. What you need to do? Update the system. So this is technically, this is not 0, but you should determine it. For determining it, you need to apply the gradient descent approach. Gradient descent approach. In this situation, my children, if I say this hypothesis function can be expressed in somehow, I represent some kind of an index value. Okay? Or if you are considering in form of a vector, both are the vector. And I told you in vector notation you need to take the transpose. I just ignore this. Okay? So like this. For multiplication of, okay, weight value vector with the feature vector, I am taking the transpose of it. Is it okay?
Yes, sir.
But of course you need to sum up all the index values.
Yes, sir.
yes
So I2, or you can say n feature. And in this situation, if I say like this, okay, or sometimes you can start it from the 0, okay, in the range, in the programming language you can use it. And I told you people, this one is the predicted one. This is the predicted one, okay, this is the predicted one, and this one is the benchmark. If you are getting the difference of both, you will get some error. And this error is representing somehow cost function. I told you people, this one is the cost function. Difference of both. Which one? this one. And once, okay, you also know the concept of this scale, least square error. And in case of m number of example, if you are considering the m number of example, so you can use this, okay, as a substitute in start. In case of houses price, I said you can visit to the m number of houses. For example, 10 houses, 30 houses, to determine the prices. So you are this is the cost function and this is the formula for it. If may I ask in exam, please write down the cost function. You will write this one. Cost function.
So what is 1 by 2?
Least square, basically just think it like this, okay?
What is 1 by 2?
Yeah, this is brilliant question. No, not slow. Around the globe, people are very much genius, okay? Like you. They notoriously add something for getting, okay, accurate solution. Let me explain how you can get a better solution by addition of it. M is number of example. For example, if I said that I want to split, okay, divide the 100 rupee bill, okay, in 10 notes, then what will I do? I will divide with 10. Then you will get 10 bill, 10 note of and 10 rupees. So you will sum up all, you will get 100. In the summation case, because there is some kind of, okay, summation concept, this is summation. Are you getting the point? So once you will divide with m, you will get some kind of a unique figure among the m number of examples, whatever you want to calculate. And this too, if you are taking the gradient, this is two. Basically you need to take the derivative. Once you will take the derivative, this two will be cancelled out with this two. So intentionally, this is adding up intentionally here. Okay? So, for example, we are using the socks in our shoes just for comfort purpose, okay? So, if we do not use the socks, then still we can use the shoes. But are you getting the point?
Yes, sir.
Yeah, to get the better accuracy or more comfort zone. So, the problem is here, very complex, okay? In the gradient descent approach, basically what we want to do, we want to update this weight value. From where? From 0. Once we don't know about it. Of course, this is somehow kind of index which go like this, and this represents what? Iteration in the loop, programming loop, okay? First loop, then second loop iteration, then the third iteration. It is, let me explain it to you people. However, it is starting from this, and it will be, there is some alpha is some kind of a step function. I will explain it also. And of course, you are taking the partial derivative. You already studied about the derivative and the partial derivative with some particular variable, okay? So here we are taking the derivative of the cost function with respect to, okay, so like weight parameter theta, not the x variable, not with respect to the feature value. We are taking, because in this cost function, you are having some kind of a variable, but we are, okay, you know what's the hypothesis function? Hypothesis function is look like this. So this is there are many parameters involved, okay, weight parameters. So we will consider here partial derivative with respect to the weight parameter theta. Because we don't want to disturb, features are the constant. For example, number of windows in this room, these are the constant, kind of fixed thing. Maybe next building, again fixed, okay? Again fixed. We do not change the features of any particular building. but we can, okay, for example, make a good color quality, okay, quality color of it, we can improve the quality of the building. Are you getting my point?
Yes, sir.
So this is so we are considering the cost function value by improving its quality, but the basic structure cannot be changed. Number of doors cannot be changed. However, by cleaning it, okay, of course, it look like this end, so we can change it.
Improvement.
Yeah, of course, improvement. So this one, alpha, is a step function. Alpha is a step function, it look like this. For example, you enter in this room, it's too much messy, everywhere. In just one, okay, blow off, you are, okay, you cannot clear the dust. Though you will use the vacuum cleaner, but you will take time from each nook and corner, okay, to clear the dust. So slowly, if you will say just one, if alpha is too big, then the problem will not be resolved. If, yes please.
So this formula artificial intelligence will इस्तेमाल होता है ये बता दो.
Yeah, to determine for the weight value. Yeah, this is, can you please see this one? Yeah, I told you that this one weight value of lesion. To determine the intercept value, because as in my previous classes, I told you that you need to consider the weight factor. And theta is what? Weight value. Intercept value.
Yes, sir.
If you started somewhere, you already familiar, okay, understood the intercept value, you don't need of it. But in the machine learning cases, like the Markov model, you don't know the history. Then you need to know the weight value from the scratch. You consider here at this point 0, but so of course it will be updating, okay. How, or let me explain the operation. For example, this one is the A. Yes, please.
Give us a little brief about weight.
Yeah, weight value. Okay. You are looking, stand up, come here, come outside. Stand it. Yeah, mashallah. What is your nice name? Zan? Yeah. Zan really looks smart, mashallah. If he did not get a good hair trimming, then you can say not very good, but today he looks very smart.
Yes, sir.
Yeah, very decent clothes. Yeah, each and this just consider his hair trimming looks smart.
Yes, sir.
Are you getting the point?
Yes,
Not
sir.
like me, okay? So, very sober and decent person. So, your personality weight is good due to your hair trimming. So, the weight of, yeah, this is please. So, the weight of your personality is increased by your hair trimming. This is the weight about your hair. How? By trimming. Yeah, you don't understand English? Okay. I mean to say कि आप अपने बालों की आपने कटाई करवाई है ना, तो आपके बाल अच्छे लगने लगते हैं, आपकी पर्सनैलिटी का पार्ट है।
ये बॉर्डर की एक्यूरेसी बढ़ाता है।
तो इससे क्या हुआ कि आपकी पर्सनैलिटी निकल आई है, तो ये आपका एक अजाफी मतलब है, प्लस पॉइंट आ गया ना, ये प्लस पॉइंट क्या है? Okay, you can say that आपकी personality का बदल बढ़ा, personality की quality बढ़ गई है ना, ऐसे ही है कि नहीं? ये तो नहीं है कि मैं आपको 2 किलो का वजन बढ़ाना लाजमी है, वजन का जैसा कि यार आपकी बात बड़ा वजन रखती है, उसका वजन आपने कभी नापा है? ये चीज़ चाहिए ना, छोटे बच्चे ना बनो।
Child.
Okay, please. Everything. Yeah, I know you people are genius, but don't become a Just leave it. That's okay. Okay. In case this one, okay, let me make it more simple. Then only. Then this is, you start some business, you don't have anything in your pocket, okay? For example, you want to sell out some, okay, stones on the roadside. You don't need any investment to collect a small particle of stones. You are collecting together, then you are trying to sell it.
Yes, sir.
In start, you have 0. Here, value of A is
0, sir.
0. Of course, this is 0. But once you are sell out one bucket of the, okay, stone marbles, then it will update it and it will become A plus 1. Now this 0 becomes what? 1.
1, sir.
Then again you are selling out.
Again.
So iteration. This is stored here.
A plus 2 yes, sir.
So this is the initial A. So again plus 1. So here if the stored value come to here. So it 1 plus 1 2.
2, sir.
Then again this 2. Okay, this iteration here stored here. This is the iteration. Basically in the starting from the 0. Weight value is 0, okay, so updation purpose, so it is storing, okay, if you are improving the quality, okay, you are losing your weight, you are become a gymnast, okay, you are doing wonderful exercises, good sportsman, okay, so you are studying hard, your personality for your parents and family become shining star.
Yes, sir.
Is it okay?
Yes, sir.
Yes.
Inshallah. So these are the, but in one moment, alpha is a step factor. Because what happened? You are changing. You are changing yourself. You are grooming yourself slowly
Yes, sir.
with some amicable step. If alpha is too big, for example, as I told you in start that cleaning the room in one go, it is not amicable.
Possible.
But amicable step, you can improve yourself, your personality. So alpha is kind of a step. You are changing, and your change will be multiplied with some kind of a reasonable steps, okay? So, when we spectate away from this, and this is kind of a negative, basically, your value, this here, weight value is increasing, and after, forget about the negative sign, okay? Forget about the negative sign. I will explain to you little later. So, it is changing, like this here, at interpretation. Is it clear, please?
Yes, sir.
Can I go back to this? This is because important, okay? Because here the important thing is what? At the moment, to take the derivative of this. How we can take the derivative of this? Let me go to this, okay, function, cost function. Take the partial derivative. So, if both sides so you can say that 2
derivative.
are you getting it? Is it okay?
Yes, sir.
But again you need to take the partial derivative of this one. So in this situation, this is, we have some kind of,
सर हमने cos के अंदर एक चीज ऐड की थी सर 1/2 हम h नॉट h थीटा x माइनस y स्क्वायर वो तो cos फंक्शन आ गया फिर इसके साथ ही क्या चीज ऐड की
Minus y.
yeah, you don't know how to take the derivative?
वो तो आता सर
Then this is the, okay, here scale. This one you get rid of scale. Then inside of this.
Angle.
This is the inside. Okay, first you deal with this one. Okay, so this is.
ठीक है सर
Is it clear? Yes, sir. So this one is the left inside. So you are, because this involves some kind of a weight parameter theta. That's why you are taking the partial derivative again. And my children, if you actually you people are genius and I am really okay in trouble, but here at this moment. You people familiar with this?
No, sir.
No.
No, sir.
No.
Okay.
Yes, sir.
Do it please yourself.
Yes, sir.
Yeah, it's not a big thing, okay? Transpose of any variable, if you multiply, you will get a scale value, okay?
Yes, sir.
I don't know.
Transpose.
Yeah. Here again, if I said that, okay, we also know that and I told you that you should also consider some kind of a transpose here. Is it okay?
Yes, sir.
So if I add something inside of it, okay, just considering here, like this, okay, I am just considering this like the previous term here, this term, we have two terms here, because what will happen here? If I will take the partial derivative of this, we will get only one.
Yes, sir.
Yeah,
Minus one.
then one. Are you getting my point? So you will have this.
माइनस वाई जीरो हो जाएगा पार्शियल हो जाएगा ना माइनस वाई जीरो हो जाएगा सर
Yes, I. Yes, please. You don't know what should be the partial derivative of this one. This will become 1 and y 0, okay? 1 multiply with all this whole term.
Remain same.
Same. So, if I say like this, now you don't have any. Only m number of examples. Is it okay? Any question until here?
No.
Instead of this, okay, we can write do you have any objection?
No.
Okay, and according to this situation, can I, okay, because both are, you can also express this z scale in, so
Z transpose.
I can,
गेट स्क्वायर
is it okay?
Okay.
यस सर
Now, for a moment, okay, just leave this term 1 over m. Okay. So multiply this one, okay, here. Multiply this term, this term, this term. Yes, please.
देयर विल बी स्क्वायर
Yes, please.
1 by m
Yes.
how is possible
This is the z scale. Okay, we can express the scale term in this form. These are all product of, okay. I told you should study it by yourself. Yes. And there are this. Suppose this one is the z, and this one is the z. Technical becomes z scale.
Yes.
Yes, sir. Okay, I intentionally consider the transpose because I want to multiply the two, okay, magic whatever.
so simple Sir, 2.
Your one.
Yeah, I'll get it, sir.
Here, please. Yes, sir. This one is the transpose. I multiply this value with this one. Of course, this will contain some kind of a transpose, multiply with this. Then again, this multiply with this. This does not have any transport, so transport negative sign. Now multiply this negative sign with this one. Again, the negative sign. So this negative become positive, and one y transpose. So you will get y transpose.
Yeah.
There is a mathematical term trace. The trace of transport becomes like this. So what is the trace basically? Trace like in the crime scenes, police are tracing the some
Clue.
evidence. If we see the matrix, this one is some kind of a matrix. If I am talking about this envelope of this sack, of bag, the volume, you use the in form of a matrix, you will use the determinant to determine its volume. But if I say what about this total length, this the purple string length, then of course you will use the trace. Trace is basically represent some, for example, this one is some matrix A11, ANN, diagonal values. So how it works in AI? In AI we are using some sensors, for example, to determine the temperature of this room. Sensors are not at all the room, So on some maybe corner, it will tell you the temperature of this room is look like this, just like this, Trace. Are you getting my point? In the matrix, trace works like this. Are you getting it or not?
Yes.
So in this equation, this is just basically trace is some kind of a sum of the diagonal values. So here you need to apply trace on it, because in AI sense, you want to identify something or you want to highlight something. So once you will choose to it, then of course you will just I use this one, and here you will consider this thing in form of, for example, X. Remember, we are considering this. These are kind of a weight value. Basically, weight is some kind of a quality thing, But variable is important. We will not apply the trace on the variable. As I told you, people, number of windows will not be changed. But sensor can sense the quality. For example, inside a room we are standing here, by predicting the light from the window, we say outside sun is shining. We are not observing the sun directly. Trace of a light is telling us about the quality, But the sun is one, kind of a thing. So the variable is somehow different things. You should not apply trace on the variable. So here, this one, trace, of course, one will apply, then it will become scale. Weight parameter, scale. Why? As I told you that trace of this like this. Similarly, if you will apply here, then X, Y, you can say trace of this one. Here you can say that follow the green equation, So this will become scale. Okay, this will you can consider the only weight parameter theta. Okay, here again the weight parameter theta. So what will happen here, please? Could you please conclude it in a simple way? I think. This will scale. Please recall the last equation.
Yes.
Thank you. Then there are two values. There, this one and this one. Okay, it will becomes minus this one. Is it okay? Not okay. So this one, okay. So this one, as I told you, will be stressed. So minus minus for 2. Don't two values sum up, okay, like this, okay. But remember this. Symmetric, okay. You studied these properties in your intermediate or level classes. So this is so situation like this. So you can express like this. Sorry? Question please? No, you can ask question, but okay, sensible question I will appreciate. You people are really genius, our questions are sensible, I apologize. But here, now again, okay, in the gradient concept, you are taking the change, okay, change. As I want to say, if you want to target something, you need to apply the derivative again and again. For example, here, please pay attention. Objective is stopping at the standstill position. No movement in the object. You can say it's in the rest position. But if object is moving, then distance will change in motion, okay, from one point A to other point B. It will change its position. It is known as what? Velocity. It is known as velocity. If you are boosting the object, okay, in some particular for getting the higher speed, you are applying the accelerator. Then its velocity again will change. Then it is known as acceleration, the derivative. Are you getting my point?
Yes.
So your object, okay, for example, this you can say that in the acceleration you are getting like
Second derivative.
the double derivative, okay,
Yes, sir.
again change, because derivative you are to target, okay, to observe the things at particular point. Similarly, again we need to apply some kind of a gradient here, derivative, with respect to what? Okay, so weight parameter theta. Are you getting the point? No? Yeah, this one somehow equation, cost function, we apply basically the first partial derivative. Then again partial derivative at this point.
Yes, sir.
Is it okay?
Yes.
So, in this situation, what will happen here? This will, what will happen to it? Zero. There no involvement of the weight. Okay, so no weight, so become zero. Partial derivative with respect to theta. So my children, you said you studied the minima and maxima in your intermediate or level classes.
Yes.
After double derivative, you are considering the for example, maximum change
Yes.
or the minimum change.
Yes.
You are considering this left hand side term equal to
Yes, sir, finish.
zero. Is it okay? For getting the minimum, I will explain this concept of minima or maxima, but for a moment, please stay with me. So, this equation, this 2 will be considered as a common multiple. M is also considered as a common multiple. So, 2 over M. So, we will have kind of an equation inside of it. This is the 0. Of course, you will get rid of it. 0
equal to xt x theta minus xt y.
Yeah, further you can express this like this.
XT कॉमन सर कॉमन ले सकते हैं
Just please pay attention, please.
X theta minus y.
Yeah, this negative, okay, so you can express like this.
XT यस
Yeah, please try to, please.
X
As I told you people, in case of a variable, we do not get rid of it easily, okay? Remember this. So, is it okay?
या
Yes, sir.
This is the we
Find the
use the weight parameter like this, and in this AI system, machine learning, okay, known as pseudo inverse. If I do ask in the exam, what's the pseudo inverse? No.
वेरिएबल्स हैं
This equation, okay. Yeah, this 0, okay. This, yeah, you can multiply cross multiplication or so you can get rid of it. Is it okay? Yes, sir. Yeah. Cross okay, here multiply both sides m. Multiply m equal to 0, 0. Not a joke. This class is really complex, and if you take it a joke, then I will not teach you. Don't make fun of it. Things are becoming complex and complex, okay? Don't come in a class if you are not in a mood of study, please. There are many students who have some serious attention to it. Yes, sir. Many students, okay, please. This is known as a pseudo inverse. Yes, remember this, I will start from this in the next class, okay?